Dear students, welcome to another session for Brilliant Physics online classes. Today we are going to discuss a very important chapter, that is System of Particles and Rotational Motion. This is very important in a competitive exam point of view like NEET and JEE exams. There are a lot of concepts and we can expect a lot of conceptual questions from this chapter, so you should be thorough with each and every topic in this chapter. Okay, so we will be going to study one by one. So let's start with a concept called rigid body. So you just look at this shape. This is a familiar shape for you. It's a cylinder, right? It's a cylinder. So you just think, how can we make cylinder? Which all materials we can use to make a cylinder? We can use iron, we can make iron cylinder, we can use copper, and at the same time we can use clay to make a cylinder, right? So let us assume this is a cylinder which is made up of iron. Okay, so this is an iron cylinder, right? Now all objects or bodies are made up of different particles. So here also you just look at this, it is a cylinder. So this cylinder is made up of different particles. You can see 2 points in it, A and B. Okay, so just look at the points A and B and imagine I'm going to measure the distance between A and B from A to B, the distance of separation. Let it be 10 centimeter or something. So that's up to us. We can assume it is 10 centimeter. And the question is, what will happen to these points if we are applying some forces? So you just look at these arrow marks. These are showing the directions of forces which is acting on this body. Okay, I can show you. See, the forces are acting on the body, right? Okay, so my aim is actually to change the shape of this body. But what do you think about? If I'm removing the force, what do you think about the distance between A and B? Will there be any change in their position? The answer is no. But it's not same for all objects. What do you think about if it is a cylinder made up of clay? If you're marking 2 points after the removal of the forces or after applying the forces, do you think that these points will preserve their position? No, which means we can classify these objects into 2 types, right? The first one is rigid and the other is flexible. So here we are going to study about rigid body. So how can we define rigid body? That's a question. The answer is, if the particles of a body preserve their relative position in the sense position of one particle with respect to the another, right? If the particles of a body preserve their relative position after the removal of the deforming force, then we can call such an object as what? A rigid body. Hope the topic is very clear. So what does a rigid body means? If the particles of a body preserve their relative position after the removal of the deforming force, such an object is called what? Rigid body. Okay, so that's clear. Now, in this chapter, we are going to study only about rigid objects. So we are not going into the movement or motion of flexible objects. We'll be concentrating only on what? Rigid body. Now, you know that till the last chapter in the sense work, energy and power, we have been studying about translatory motion, linear motion, right? Here, from the name of the chapter itself, you got an idea. We are going to study about rotational motion. So let us try to understand what is the basic difference between translatory motion and rotational motion. Okay, translatory motion means the linear motion and the other is rotational motion. So this is very clear for you. You got an idea about what is a rigid body. Now we are going into the concept of motion of rigid body. Yeah, so you just look at this. It's a very familiar motion. Look, it's a bicycle, right? You're all familiar with it. No need to look at the wheel. You just look at the other part. You can see 2 points A and B on this cycle, right? So this part, definitely it's a rigid body, right? So A and B are 2 points on a rigid body. So when the cycle is moving on a road, you just look at how the points A and B are moving. Okay, it's very clear. There is nothing complicated in it. Now, look at the next case. This is very important. You have to analyze it in detail. Look, A is here and B is here. Here also both the points are marked. Now, when this cycle is in motion, look how the points A and B are moving. Look, B has started from here, A started from here. So when the cycle is moving, look how the points A and B are moving. So these lines, these different colors are showing the displacements of the points A and B. Displacements of the points A and B. Okay, so let us take a particular distance traveled by the cycle. After that, let's have a comparison of the displacements of A and B. Look. So look at the length of the colors. They are exactly similar, right? That means we can clearly say the displacement of A is equal to what? Displacement of B. Displacement of A is equal to displacement of B means, of course, you know, velocity is displacement upon time. So when displacements are same, what about velocity? Velocity will also be same. So the idea is very clear. This is which motion? Translatory motion or linear motion, right? In linear motion or translatory motion, the displacement or the velocities of each particles of a body are the same. Clear? The displacement and the velocity of each particles are the same. Now the question is it same in the case of rotational motion? Let's see. Remember, in linear motion, the displacement of all the particles, not only the two particles, you can take any particle on the body, you can see that displacements and their velocities are equal. Now let's go to a familiar example for rotational motion. Every day, we're all applying force on a door, either to open or close it, right? So let's take such an example. Let's see what happens in the case of a rotational motion. Look at the body. It's a very familiar object for you, right? There is a door. This is the handle. You can see this is the line across which you can open or close the door. Okay, so look at this. You can open the door, close the door. Look at the movement. It's very clear. Now, I'm going to mark 2 points on this body. Look at this. Q and P. And you can see this door is rotating about this axis. So we can call this line as the axis of rotation. So the line about which the body is rotating is known as what? The axis of rotation. So if you are looking at the distance of Q and P, are they same from the axis? No. Q is close to the axis and P is away from the axis. So it's just like in the last case, we have taken 2 points A and B on the cycle, but we got their displacements are equal. Look at this. So you just look at the movement of P and Q. You can see it clearly. These are the points. So P is moving like this, Q is moving like this. So P is taking a new position P dash, Q is taking a new position Q dash. Look at their displacements. Are they equal? It's covering this. So the displacement of P and Q, are they equal? Definitely no. So displacements are not equal, velocities are not equal. So definitely one thing is sure, it is not linear motion. We can call it as what? Rotational motion. So we need to study something more about rotational motion. For that, I'm going to another example. Okay, you are okay with this? Now look at this. This is another type of door, right? You can see it. This is a glass door. You are familiar with these type of doors. You can see I'm marking 2 points, 1 and 2 here. Look, when this door is rotating, look at their movement. One point is making a circular path. Other point is also making a circular path. But are they having the same radius? No, their radius is not same. But you can see a common factor there. Their centers are in the same line, right? The centers of both the circles are in the same line. If you are drawing a line like this, you can see that line is passing through all the centers, right? Then that line is called what? The axis of rotation. So this body is rotating like this, about in circular path about a common axis, right? That axis is known as the axis of rotation. Look how it is rotating. I think you got a clear idea about the difference between linear motion and rotational motion. In linear motion, the displacement of each particle, the velocities of each particles on the body are same, but in rotational motion, the displacement and the velocities of different particles are not same, but there is a common factor. What is that common factor? If you are drawing their circular path, you can see their centers. The centers of the circular paths are in a common line, and that line is known as what? The axis of rotation. Okay, so I think this part is very clear, and next session we will be going to the detailed study of circular motion. Thank you very much.